So let's open the OrCAD software, and it you can see that there are two options: new design and new project. So we're going to click on new project and we're going to give it a name, a file name. We are going to do Schmitt Trigger here. So I'm going to name it Schmitt Trigger and I'm typing it now. And here you can see I'm clicking OK. The name is not unique. So I'm going to give it a additional underscore so that it won't overlap or overwrite any other files. And let's click on create a blank project and OK. After that, you can see a workspace, a blank workspace is here. And in the top, you can see file, design, edit, view. In that, for selecting paths, let's go to place. Let's click on place here. So in the place, you can see many options. In that, you need to click piecewise component, and now we are going to first use the voltage source, and you can see source here. In that there are many options. In that we are going to select voltage source. In that particularly we are going to go for sine. So let's click on it. So after selecting the sine here, we are going to place it, and we are going to place other components here like resistors and all. So let's go to the place and let's click piecewise component and let's go for resistors. And in resistors, let's select other three resistors. We are going to have three resistors. So I'm going to place everything here. And then we are going to go for our operational amplifier, which is in the same place. Place piecewise component, and in the discrete section, see here, diode, inductor, and we have digital, and at the bottom we have discrete, and we are going to go for operational amplifier, op amp, and I'm going to place it here. I'm going to move it, and after placing it we are going to give it a value. So you can see the properties, the basic properties, and right click it, and you can see the values. I'm going to replace the R1 value with 220 here. I have typed it, and then after that you can see that there are many options here, and after giving it a value, the value would be changed in the circuit section. See here, the value of R1 has been changed. Let's do the same for R2. Let's select it and replace it with 2.2k, and I'm typing it 2.2k, and I'm going to do the same for R3. I'm giving it the value of 220 here, and in the 1k place we're going to replace it with 220, and we are done with this. You can see that I'm typing 220 here, and after that the change that we are made here is going to be reflected in the circuit diagram. And then let's rotate it. Let's click that particular component and press R, and here you can see, if you give right click, you can see a rotate option, and if you can see the properties here, and we select the component and type R in the keyboard. You can see it has been rotated, and I'm going to do the same for that also. And then for voltage source we have VAC here. We are going to give a value of 10. So it's basically the AC voltage that you are giving. AC value, I'm going to give it 10. And then basically you're not going to go for DC here, so you're going to give it a 0. And then beneath that you can see frequency and all, and let's replace the same for V the amplitude, and let's give it a 10. And the frequency, let's give it with 500. So we can apply it for input and output. And then let's see the properties here, and you can see every value has been given here. And let's also give it V off, and then let's connect all these components with wire. You can click the component and click W in your keyboard, and you can connect all these parts. Click on run. Before clicking it, you need to check whether the simulation buffer has been done. Here you can see PSpice. Clicking it, you can see a pop-up has been came here, and you can give it a name. And after clicking it, let's click on PSpice simulation. Give it a value here, runtime. I'm going to give it 100 milliseconds here, and the circuit is basically done here. And after that, basically what we need to do is we need to run this and check whether there are errors. Wave has been obtained. The wave is not that much clear, so we are opting for um, a smaller time period, and you can edit this by going to PSpice and edit simulation profile. You can see that here, and I'm going to give it 10 milliseconds so it will be easier. I'm going to check on a particular time period. So this is the before of changing the value of the runtime, and I'm going to show you after. I'm going to click OK. I'm going to basically run it again, and you can see it here. We have a clear output here.